welcome back. Now we're going to do some chain rule practice, which is pretty much going to be everything we've covered so far, meaning power rule, product rule, quotient rule, along with the chain rule. So you can take a second if you'd like to pause the video, try them out for yourself. I will be solving them, again, quite in detail and in depth. And yeah, don't forget to mention if you have any questions in the comments. I will be posting specific questions from the comments with solutions to them. Okay, so let's begin with question 1. Okay, so our function is y is equal to x squared plus 1 times 1 minus x to the power of 2. So we can recognize right away that over here we have two things being multiplied together along with some exponent, which means we're probably going to be using the product rule as well as the power rule. So by the product rule, just to remind you, it says that if we have 1 times 2, meaning one thing times another, it's going to be 1 times the derivative of the second one plus 2 times the derivative of the first one. So in this case, y prime, we're going to start with x squared plus 1, keep it the same, multiplied by the derivative of this over here. Just so we have it off to the side, well, what's the derivative of 1 minus x to the power of 2? Derivative of this, well, first we do the power rule, we'll bring down the exponent, leave everything in the bracket as it is, don't touch it yet. And then we have 2 minus 1, so to the power of 1. And this is where we apply the chain rule. Now we have to multiply everything by what's inside the bracket, or the derivative of what's inside the bracket. Well, inside the bracket we have 1, the derivative of that is 0. And then we have minus x, and recall that derivative of x, again, is just negative 1, right? We have that minus, and then x is 1, so minus 1. So let's just simplify this a bit. That's 2 times 1 minus x times negative 1, or just negative 2. Okay, so let's plug that in here. Negative 2 times 1 minus x plus 2, which is 1 minus x squared, times the derivative of the first one. Simple enough, x squared plus 1, that's 2x plus 0. And that is our solution. You can simplify this obviously further. I'll let you do that for practice. If you're not sure, make sure you can check out Symbolab. They're quite useful in this as well. So number 2, f at x is equal to 2x over 1 minus 2x squared. So here we have obviously quotient rule. Quotient rule meaning we're dividing something. Again, to remind you using my trick, if we have one thing divided by another, then the derivative of this is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so using that, f prime of x, let me just separate this a bit, f prime of x is going to equal to 1 minus 2x squared times the derivative of the top, which is 2x, meaning it's just going to be 2, minus the top, 2x, times the derivative of the bottom, which is 1 minus 2x squared. The derivative of 1 is 0. The derivative of negative 2x squared is negative 4x, right? So we bring down the exponent, we get 4, and then 2 minus 1 is just 1 for the exponent, negative 4x. All over the bottom squared, 1 minus 2x squared, and then square that as again. Again, you can simplify this, which means it's going to be 2 minus 4x squared plus 8x squared all over, and then whatever this gives you as well. Okay. Number 3. So we have h of x is equal to 3x squared minus 5 to the power of 4. So, and here we're going to be using the power rule, as well as the chain rule. Now recall the chain rule says it's the same format as a composite function. If we have f at g of x, that's the derivative of x, of f, when x is g of x, and then the derivative of g of x itself. So I'm going to show you this in two ways. So the first one is just 4, 3x squared, so this is the power rule, and then 4 minus 1 is 3, multiply by the derivative of what's inside the bracket right here, which is 3 times 2, 6, x, minus 5, the derivative of negative 5 is just 0, so we leave it as is. You could also look at it as by setting up f at x to be x to the 4, and g of x to be 3x squared minus 5. So now, using our composite rule here, the chain rule, we could do it that way as well. So first we take the derivative of f at x. F prime of x is just 4x cubed. But we need to remember that we need to plug in g of x into the function of f. Basically, we're saying that instead of just having x, we're plugging in the whole g of x function in there. So f prime at g of x is just 4, and then remember the x value is now the function, 3x squared minus 5 to the power of 3. And now g prime of x is going to be, so the derivative of g of x, 6x. So now that we found the information that we need, again, this is another way you can solve this if it's easier for you to break it down. We just plug it in and we say, well, h prime of x is going to equal to f prime of g of x. So 4 times 3x squared minus 5 cubed multiplied by g prime of x, 6x. Again, I'm a very big emphasizer on using brackets. It'll make sure you don't make mistakes or minimize the mistakes you make on a test, a quiz, or especially the AP test. Okay, and see, we get the exact same answer. Just depends how you prefer to solve it. Okay, question 4. If k of x is equal to 2 times 5x squared plus 3x to the power of 3. Now this looks like a constant multiple rule, right? We have that constant in front of the whole big function, as well as the power rule. So let's start. K prime of x is going to equal to, we're going to leave 2, we're not going to touch it just yet, and we're going to bring down the 3 and multiply it by the entire bracket without touching it. And then we have 3 minus 1 is 2. Now we multiply all of this by the derivative of whatever was inside the bracket. So 5x squared plus 3x, which gives us, again, power rule here, we have 10x plus 3. Okay? So that's the first way to solve this, and then you can simplify it further to see what you get. The second way to do this, you could also just use the product rule, which for someone, again, who's not as experienced, you might prefer to use this method because it'll help you break it down a lot more. So we have these two terms, 2, and then this whole big thing that's cubed. So we start with k prime of x. Again, you can look over here, right? This is our product rule. So k prime of x is going to equal to 2 multiplied by the derivative of this big cube thing, which is 5x squared plus 3x to the power of 2. And again, we're multiplying it using chain rule. We're multiplying by whatever was inside the bracket, the derivative of that, which is 10x plus 3. Again, more brackets, plus 5x squared plus 3x cubed times the derivative of 5, which is 0. And this constant, oh sorry, not 5, the derivative of 2, which is still 0. This constant is the reason why these two methods still give us the exact same result, because this 0 cancels out this whole term. And we still end up with the exact same thing. Let's do number 5. So we have g of x is equal to 2x squared minus 6x plus 9 to the power 7. So this one is a little more formal of the chain rule as well that we covered above over here, right? So it's the power rule right here, and then you multiply by whatever u is, right? Or whatever's inside the bracket in our case over here. So g prime of x is going to equal to 7, right? Bring down the exponent. 2x squared minus 6x plus 9. 7 minus 1, that's the exponent, which is 6. And now you multiply by everything that's inside the bracket. So the derivative of that, so 4x minus 6. And you're done. Okay, number 6. Same idea, we just did something similar. I'd suggest you try this on your own first before you keep watching the video. Okay, bringing down the exponent, we have 4 and then that 5, so multiplying by 5, times everything that's inside the bracket. So 2x cubed minus x squared plus 3x. 5 minus 1 is 4, that's the exponent. Multiplying by the derivative of what's inside the bracket, so 6x squared minus 2x plus 3, and now you're done. Okay. Number 7. Okay, see, it's getting a little fun. It's getting quite redundant, but it is fun once you get the hang of the rules. So for number 7, I'm not quite sure why I forgot to mention the y in there, but I'm just going to plug it in. Y prime is equal to. So I am going to use product rule here. So we start with number 1, so x plus 1 squared. Now we multiply it by the derivative of x plus 4 to the power of 3. Now, it might be beneficial to actually split this up and find the derivative of each of them on the side here. So let's say x plus 1 squared means the derivative of that is 2 times x plus 1 to the power of 1. And then the derivative of what's inside here, well, the derivative of x is 1, and the derivative of 1 is 0. So it's just 1 multiplied by 1. That's why it's redundant, so we just kind of don't even write it. And then for x plus 4 cubed, derivative of that is going to be 3x plus 4 to the power of 2. And again, the derivative of x is 1, the derivative of 4 is 0, so it's plus 0. So it's just times 1, right? And now we'll just use that. So we have x plus 1 squared multiplied by the derivative of the second term, right? This is number 1, this is 2. The second term has a derivative of 3x plus 4 squared. We're going to add cool. We're going to add now the second term, x plus 4 cubed, multiplied by the derivative of the first, which we wrote that down here. So 2 times x plus 1. And then the next step would be to just simplify everything further. Now, some of your teachers might not actually require you to simplify it. Some of them, especially when you're just learning, they'll ask you to just show that you know the rule. Okay, number 8. Same idea, term 1 and term 2. Again, it might be useful to just kind of on the side write down the derivatives of each. So 3x squared minus 2, 3x minus 2 is just 3. Derivative of 5x squared to the 3. So that's 5x squared to the power of 2. So number 8. It might be beneficial to write down the derivative like so, is what we did here. So 3x minus 2 is 3, and then 5x squared to the power of 3 is 3 times 5x squared to the power of 2, multiplied by the derivative of what's inside the bracket, which is 10x. So again, y prime is going to equal to the first term, so 3x minus 2, multiplied by the derivative of the second, which I'm going to rewrite this as 30x times 5x squared to the power of 2, and that's 30s from here, 3 times 10x, plus the second term, 5x squared to the power of 3, multiplied by the derivative of the first term, which is 3. Again, we figured that out over here. Number 9. Same idea, we've done practice like this before as well. I think it was, say, where was it? Yeah, I guess question 7 as well. So I'm just going to kind of zoom by it. So we have 5x plus 9 to the 4 times 3x minus 2 cubed plus x plus 9 to the 5 times 3x minus 2 squared times 3. Now, let me just break this down a little bit. So this is the first term, second term. We took the derivative of the first term, multiplied it by the second term. Then we took the first term and multiplied it by the derivative of the second term. Great. Okay, last 3. Number 10. Again, y prime. Ooh, I think for this one it really would be useful to break them down. So let's say this is 1 and this is term 2. So for number 1, we have the function x squared minus 5x to the power of 2. The derivative of that is going to be, again, bring down the exponent, 2 times x squared minus 5x. Don't touch what's inside the bracket yet. Subtract 1 from the 2, so that's just 1. Now you multiply it by the derivative of what's inside the bracket. So x squared minus 5x, that's 2x minus 5. Now the second term is 3x cubed minus 2x to the power of 5. And the derivative of that, again, bring down the exponent, 5, 3x cubed minus 2x, we're not touching the bracket yet, to the power of 4, and now we're multiplying it by what's inside the bracket. So the derivative of that is going to be, we have 3, and then bring down the exponent, which is another 3x squared, minus derivative of 2x is just 2. And then you simplify that down. So by the product rule, we know that's 1 times 2. Derivative of that is 1 times 2 prime plus 2 times 1 prime. Again, order doesn't matter, so you can also just say 1 prime times 2 plus 2 prime times 1. So let's solve that now. Y prime, and we can just kind of plug things in. The first term, x squared minus 5x to the power of 2, times the derivative of the second term, which is this huge big thing here, 5 times 3x cubed minus 2x to the power of 4, multiplied by 3 times 3 is 9, so 9x squared minus 2, brackets, 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 plus the second term, yeah, these get quite annoying, to the 5, multiplied by the derivative of the first term, which is 2 times x squared minus 5x times 2x minus 5. Okay? Yeah, I know, it's quite a lot. Let's just not cry about it. We persevere. We move past it. Okay, 11, 12, and 13 are all quotient rules. So, again, quotient rule says we have 1 divided by something else. The derivative of that is the bottom times the derivative of the top minus the top times the derivative of the bottom all over 2 squared, which is the bottom squared. Okay, so again, it might really be useful to split these up. So let's do that. I feel I must move h of x. Let's move you over here. Mind you, these get quite long, so make sure you have some space in your notebook. Okay, let's start with the top one. So we have 2x plus 1 cubed. Derivative of that is 2x plus 1 squared times 2. 3x minus 2, that's the bottom one now, is 2 times 3x minus 2 to the power of 1 times 3. Okay, so h prime of x means we take the bottom times the derivative of the top minus the top times the derivative of the bottom. Please, please, please make sure you're using your brackets. Every time you add something new, add a bracket. It's going to help. Over the derivative of the bottom squared. So 3x minus 2 squared, and then square that. See, brackets, brackets, brackets. Please make sure you practice simplifying it. Okay, number 12 and 13. Let's go, we're almost there. So g prime of x. We take the bottom denominator, okay, multiply by the derivative of the top. So 5 times 4x plus 5 to the power of 4 multiplied by the derivative of what's inside, which is 4, minus the top times the derivative of the bottom, which is 2 times x plus 3 times 1 all over the bottom squared, so x plus 3, and I'm just going to do to the power of 4. So that's the quick note that x to the power of 2 squared is just x to the power of 4. Okay, last but not least, number 13. I'm going to add these brackets in here. F prime of x, take the bottom, 8x plus 1, multiply by the derivative of the top, so 4 times 2x squared minus 5 to the power of 3. Now I hope you're getting to the habit, making sure you multiply by the derivative of what's inside the bracket. So 4x minus the top, 2x squared minus 5 to the power of 4, multiplied derivative of the bottom is just 8, all over 8x plus 1, which is the bottom denominator, squared. If all of these made sense and you were able to solve them all on your own, or at least understand everything I was doing, well done. If not, please make sure you ask me some questions.